Now remember, this is a sort of a scalar kind of division. So the whole series, every cell is divided by a constant. And because it's lambda, the whole series is automatically returned as a value. And it's valid because a series is a structured object, is a value, it's one value. So it's automatically returned. And then df3 dot apply, the function, will receive this modified series and then overwrite it on the column. Okay, and then return the whole data frame as a new copy of data frame. Why? Because you always don't modify it directly. When I say modify, the data frame column is that dot apply already prepares a copy of it and then modifies that copy, right? So again, we can also try to apply the lambda across all the cells. And the way we do it is dot apply map. And because series uses map, so it kind of sounds right to say, I want to apply, but apply is a data frame only kind of spelling. Series never has a dot apply. So dot apply, but I like to go through all the cells. That's a bit like series. So put a map behind. So dot apply map, the lambda, take whatever scalar value you have. If it's 8, then receive an 8 in x. 2 times that, you get 16, right? Then we get 3 and we get 6 because it's 2 times 3. 9 becomes 18, 18, right? And 107 becomes 2 times 1, 2 times 0, 2 times 7. And it doesn't matter if dot apply map goes by row or column by column. The end result is the same. So we don't really specify how, in what direction the apply map should go. And that is the too much detail for us to control. Okay, so this makes it very short and sharp, very powerful, especially when used with lambda. It's kind of like define, use, and forget, right? So really powerful function that we have here. Instead of lambda, of course, we can also use traditional, I don't really want to use the word traditional, our usual def functions to record whatever we want to do. And sometimes it's complicated, or having some sort of a for next loops to do complicated access and check dictionary and condition only if this happens then that. Then finally we get a single outcome. All right. So in this case, we can also return appropriate value. So for example, if it's dot apply, make sure we return a series. If it's dot apply map, meant for use in the dot apply map, we return a scalar value. So we can definitely use our traditional function. Sometimes it helps, sometimes it's worse, right? If it's a quick use, apply, and then forget, I don't really need to use this function again, lambda is probably a better choice. But if it's going to be lengthy like this here, my version of transformation, my map, and it's going to, what is it going to do? It's going to transform each row's maximum value, like in this case 83999 is maximum, to its own first quartile value. So find the first quartile value, the 25th percentile, yeah, and then what is it? And then replace the maximum value sign. Okay, so that is a wow, right? Pretty. I mean, it's not impossible, especially if we use the numpy's dot quantile, so we don't have to worry about how to calculate. Just run that function will do. But we still have to look for max, and then found the max, and then replace it like this. So if you use lambda, it's not possible because we need to scan over the values of the given row series. And for loop is not allowed. Changing the state of the local variables not allowed in lambdas. So impossible. So therefore we define our function and then we say apply our function, and we know it's basically applied towards either column or row, but now axis says apply to the row. Axis equals to 1. And we remind ourselves that the input value that apply will send to us is always a series, but we should think of it as a row because we will use it in conjunction with x is equals to 1. Now you might be asking, what if I define row vec like this and I put x is equals to 0? Now you're going to get into a lot of trouble because um, it may work because while you call it row vec, apply is going to send the column to you, and to the extent that you can still find some meaningful proportionate quantile towards two value kind of situation, it will still work, right? It will still work. And the max is 9, the max is 3, and so on. But then when the output comes, you will get a shock because it's totally not what you want. Okay. And then of course we if the mapping function returns a scalar, okay, then one dimension is reduced and we get a series instead. So the apply may accidentally change. Well, when I say accidentally, it just means that if you're not careful, you might be caught off guard. It might not always return the same size as your original data frame. So in our data frame here, we want to change the values from a row perspective, but not changing the dimension. Why? Because the quantile is calculated based on the row, not by the column. So there's a row perspective to it, but we are returning each value based on the same shape, same dimension. There are times when, for example, like this, df3.apply, right? And we base on the row. So we supply 8399 inside. But our function, we use a standard function, the numpy's average function, the np.mean, which takes a series and returns the average. So it converts one-dimensional value, the series, into zero-dimensional scalar form, an average scalar value. So when you do that, the return value is going to shrink from 4 columns to 1 column, right? Yeah, because you're returning one value for each row. Therefore, in the end, you will get just 1 column instead of 4 columns. And when it's 1 column, Panda says, or dot apply says, wow, it's 1 column. More efficient to return as a series than the data frame. So what this means is, if you do this, you should know what you're doing. Your function should, I mean, all these are predictable, right? You know what it's going to be for when you use np.me. So you need to know that your return value is going to be basically a series and not try to access the dot columns, which doesn't exist, all right? And not try to do second column, third column, dot ilog, dot whatever it is, that don't make much sense for a series, right? So you need to be able to sort of adapt to such situation when the data frame collapses into a series. So just be mindful of that. Okay. Now, very excited now. I hope we are going to step over to our lab to play this out. Okay. So join me in the lab in the next video discussion.